We are looking at land and water use, and one of our major uses that we have on land is agriculture. And so we are going to be taking a look at how we use our land in this way to make us food, and maybe what are some better ways that we could go about it.
Um, Farming is a huge land use that we need to talk about. And really, the biggest effects happened when the Green Revolution came around the 1940s, 1950s. And so there's this major shift in agricultural practices, and those have massive effects environmentally. And so the Green Revolution dramatically increased per acre yield. So if you look at the graph below, right, you have the amount of area that's harvested in that green line, and then the production and the yield went up over the years. So from 1960 onwards, we have this increase of production on the same area that we were using before. So we can make more on the same amount of land. And so like I said, like it started 1940s, 1950s, but mostly in our cash crops. So wheat, rice, corn, now soy, and it depends on a lot of synthetic fertilizers, chemical pesticides, very irrigation heavy, and also the use of very heavy equipment, like the mechanization of agriculture. So let's look at those impacts and, you know, how those parts of the Green Revolution actually impacts us now. So one agricultural practice is called slash and burn. And what they do is they cut down the trees and vegetation, they put them in a big pile and burn them down. And so what that gives us is very nutrient rich ash. And however, the trees aren't there to hold those nutrients into place, and it gets depleted very quickly. And so because the plots are only used for a few, or because of that, plots are only used for a few years, and then you move on to the next part. But what happens is that due to demand, those plots are used too frequently to recover. So usually they need a few decades to recover, but really what's happening is they're coming in every few years. So you have this um, massive depletion of nutrients in the soil. And so if we're depleted in nutrients, we're going to add fertilizer. And so there are two real kinds of fertilizers. Like I said before, in the Green Revolution, synthetic fertilizers is really they're heavily dependent on in conventional farming, but there are organic fertilizers as well. So organic fertilizer is just made up of organic matter, so whether it's plant or animal. So crop waste, it just being the stalks of corn or whatever it may be. Whereas if you use animal organic matter, that's their manure. But either way, those are actually really good for beneficial microorganisms, and so it really sustains the soil. It feeds those microorganisms, and that organic matter also contains micronutrients, so not the big macronutrients that are nitrogen, phosphorus, potassium, but also other smaller nutrients that plants need for growth. Maybe a drawback of organic matter is that they're not as readily taken up as the synthetic kind, which we'll talk about in a second. But what is great about that is that, right, it really supports the soil structure and doesn't kind of throw a band-aid at the problem. As opposed to synthetic or inorganic fertilizers, these are produced commercially, and so in order to produce them, natural gas, the fossil fuel, is combusted to fix nitrogen into the fertilizer. And you end up with this end product, that white granular material that you see at the picture to the right there. But You get super highly concentrated nitrogen, and it's much more readily available for uptake than organic fertilizer because it doesn't have to go through that, that nitrification process. However, it is more likely to run off and leach down because they're water soluble. So when you have precipitation, those chemical fertilizers either get um, sorry, get put into solution in the water and then run off the top, or percolate down into, groundwater. So those synthetic fertilizers are water soluble, and the organic fertilizers are not. Tilling is another practice, so where you turn the earth over or break it up and loosen the soil. It's great, and we use it because it removes weeds and any unwanted roots. It also makes planting seeds a lot easier. However, it does cause more erosion because the living matter that was there is gone, and so it's not holding it into place. And also, right, that decaying organic matter is gone, so it's not going to feed into the soil. Not to mention, just in general, you actually have loose soil, so it's just going to kind of come off through winter water. Tilling is done through mechanization, and one of the things we did in the Green Revolution is that we mechanized agriculture. So through plowing or planting, irrigating our crops, weeding our crops, whatever it may be, even harvesting, sorting, and preparing foods for sale, all of that has been mechanized. And so obviously labor costs are very high when you don't have to pay people to do it. It's worthwhile, and fossil fuel costs are low. So, the cost benefit there is actually pretty beneficial if the farms are big enough to recover the cost from actually buying the machines in the first place. And so these large farms can recover the cost because they actually have enough land to produce the food, whereas small farms really don't have this opportunity to do it.
So now we're going to take a look at sustainable agriculture. How can we grow food on land without depleting our nutrients and our soil and our water in order for us to have food for years and years to come? I do want to point out that rotational grazing is part of this 5.15. I talked about it in a different PowerPoint, so I won't be talking about that this time. So basically, soil conservation is reducing erosion. Traditional or conventional agriculture leaves the soil exposed to runoff and erosion, and so in sustainable agriculture, we want to really make sure that our soil doesn't go anywhere. And so there are a few methods in doing this. Before we talked about tilling our soil, and there's a method called no-tilling. And so basically, you leave the residue from previous years in place, and what that does is it makes a cover for that soil, and it can prevent the soil. It also leaves the root systems in place, and so the soil is still locked into place with those root systems instead of tilling them up and disturbing those root systems. And the next one, if you look over to that middle picture, is contour plowing. I think it's so beautiful. Basically, instead of plowing in straight lines, you are plowing in the contour of your land. So you're just following the curves of the land as opposed to fighting against them. And what that does is it allows the water not to run off as fast, and you're going around, so you're like creating barriers or to the water as it's flowing downhill, as opposed to basically giving it channels to do it. And then on the bottom, also I think is so beautiful, is called terracing. And by creating terraces, it's also slowing down that water runoff, that surface runoff, and allowing the water to kind of sit for a bit before it runs down, and ultimately will end up increasing infiltration. So strip cropping is another method of soil conservation. And you can see there in that bottom left picture, basically you have strips of different crops along the natural contours. Again, right, working with the natural contours of the land will allow the water, not the surface runoff, not to run off as fast. Another method is called windbreaks. In this middle picture here, you can see that you have rows of trees planted on really to block the wind coming into your crops. It slows down the wind and it's protected. And so basically, instead, in this point, we're really talking about wind erosion as opposed to water erosion. And so the slower winds means that not as much soil is going to get picked up. Perennial crops are also really important, kind of in the same vein as no tillage, right? You're leaving things in place, but in this case, you're actually planting crops that will come back. So as the plant grows over years and years of growing, that's what a perennial crop means. An annual crop means that you have to plant it every year. The perennial crops will come back year to year. And so the roots are staying in place and they're developing. And I love this picture. I think it is so telling on what a perennial crop can do. The more roots you have, the more locked into place that soil's gonna be. And so you can see, look at the annual crop on the left versus the perennial crop on the right. In June, right? So in September, there's nothing. And then come June, there's a root system there on the annual crop, but it's not as deep and locking that soil in as much. And so it really locks that soil in. Love this picture. Okay. Another thing that we need to take into account is soil fertility. One of the major downfalls of conventional farming is depleting the soil of nutrients. And so you have the three main nutrients, the macronutrients. You have nitrogen, phosphorus, and potassium, NPK. And so if you look on a bag of fertilizer, those are the numbers. So you might see numbers on your fertilizer, and that's what it's denoting. It's denoting how much the ratio of nitrogen, phosphorus, potassium. And we can avoid using chemical fertilizers, and organic fertilizer. Well, we'll talk about green manure, which is basically an organic fertilizer. But anyway, but you can avoid having to add to your soil by taking care of your soil in the first place. And so one of the main ones that I think is so important is something called crop rotation. And so you are planting crops in a certain area, and then the next year you would rotate it to the next plot, and hence crop rotation, right? So you're using the same field, but you're planting different crops in there every year. And in doing that, there are so many benefits. You lessen pests and insects because, let's say, if you look at the diagram on the right, my tomatoes and my fruit plot, right, they get lots of aphids, let's say, but aphids don't really like legumes. So, right, if I plant legumes there, the aphids that are sitting in the soil waiting to eat the tomatoes when you plant them again, the tomatoes aren't going to be there. And so your pests will actually lessen because you have different crops in that place, and different pests like different things, and so therefore if you don't give them what they like, they'll decrease in population. Another really big thing is different crops use different nutrients. And so, for example, let's say, again, we'll go back to like tomatoes, which are like actually pretty nitrogen heavy users. They love nitrogen. They just eat it up. Num num num, right? But then, if I were to rotate through, maybe the root vegetables don't use as much, and legumes are actually nitrogen fixers, so they'll actually lock nitrogen into the soil. And so when the tomatoes come back, I'll have lots and lots of nice nitrogen in the soil there for them. Whereas if I planted a nitrogen heavy plant in the same place every single year, I would need to amend that soil with more nitrogen. So, speaking of nutrients, right, green manure is leaving the crop residues there, like I said before, and so basically you're using it as mulch. You're covering over, you're reducing weeds, and it's also composting and getting its good nutrients into the ground. And one other way that we can help soil fertility is by adding limestone into the soil. And what that does is limestone is known as a natural buffer, and it neutralizes soil acidity to promote the good bacteria in the soil that do that nitrification process for the plants. It is so important to take care of your soil, right? If we just throw a Band-Aid on it by putting chemical fertilizers on, we're just going to have to keep doing that, right? We're going to have to keep applying it. Where if you get down to the root, get it? Pun intended. Okay? If we get to the root cause, I cracked myself up. To the root cause of the fertility, right? If you are feeding that soil and taking care of your soil, the soil will take care of your plants. And so, right, it's really fixing it the right way instead of fixing it the fast way.